In my previous video, I had explained Lagrange's linear partial differential equation and method of finding solution of such type of equation, and also first three problems which I had listed here. Now I will be discussing fourth and fifth problem which is written here in the present video. So now consider the fourth question, that is xp minus yq is equal to y square minus x square. So first of all, you identify this as the Lagrange equation of the form P plus QQ equal to R, where P is x and Q is minus y and R is given as y square minus x square. So now for solving Lagrange's equation, the first step is writing auxiliary equation. So auxiliary equations are of the form dx by p is equal to dy by q is equal to dz by r. So in this case, dx by x is equal to dy by minus y is equal to dz by y square minus x square. So now for finding solution of the first equation, that is the question, now it is enough to find out two independent solutions of the auxiliary equation given by second equation. For that, you have to find out two ratios which can be written in the variable separable form and hence which can be integrated. So you consider the first and second. So then you know that here you can see that dx and dy are differential coefficients, and denominator it contains only x and y. There is not any term in z, so that easily you can integrate. So now taking first two ratios, we can write it as dx by x is equal to dy by minus y and now integrating we can write this is log x is equal to minus log y plus constant of integration, I'll write it as log a. Now this becomes log x plus log y equal to log a, or we can write it as xy is equal to a. So this is our third equation, and now this is a solution of the auxiliary equation given by equation number 2. Now you have to find out one more independent solution of the auxiliary equation. For that, you have to find out another two ratios which can be written in the form of variable separable form, or which you can write in the form of an exact differential. But here you see, if you are taking first and third ratio, differential coefficients are dx and dz, and here this term contains y square and you cannot eliminate this. And again, if you are taking second and third also, this x square is there and you cannot eliminate this x square. So therefore, if possible, make use of any properties from ratios and proportion. And from ratios and proportion, you know that if a by b is equal to c by d, then each ratio will be equal to a plus c by b plus d, or this will be equal to a minus c by b minus d, and like that you can find new ratios. For example, you know that 1 by 2 is equal to 5 by 10, and this is also equal to 1 plus 5, that is 6 by 12, and this is also equal to 5 minus 1 is 4 by 10 minus 2, that is 8. So all these ratios are equal. So therefore, we will make use of this property in this case for finding second independent solution. So therefore, you consider the first and second, not this one. Okay, consider the first and second. From first and second, we can write one new ratio, that is dx minus dy by x minus y. So now we can write each ratio of equation number 2 is also equal to dx minus dy by x minus minus y, that is x plus y. Now you consider the third ratio and this new ratio and prepare one new equation. So that you can write it as dz by y square minus x square is equal to dx minus dy by x plus y. Now then this y square minus x square can be written as dz by y plus x into y minus x, that is equal to dx minus dy by x plus y. We can cancel these two terms and now we can write this as dz is equal to y minus x into dx minus y, or this is equal to minus x minus y into d of x minus y. So now you know that integral x dx is x square by 2. Therefore, what will be integral of x minus y into d of x minus y? That will be x minus y the whole square by 2. So that we can integrate this equation. Now integrating, this integral of dz is z, that is equal to minus x minus y the whole square by 2 plus constant of integration. I'll take it as b1. Now simplifying, you can write it as 2z plus x minus y the whole square is equal to 2b1, or I'll write it as 2z plus x minus y the whole square is equal to b, another constant. So now we got two solutions of auxiliary equation given by second equation. So this is our auxiliary equation. Now see third equation, that is a solution of the second one, and also fourth one is also a solution of the auxiliary equation. Therefore, by the theorem, we can write it as the general solution of the given equation. General solution of the given equation is of the form f of uv equal to 0, where in this case u is xy and v is 2z plus x minus y the whole square, that is equal to 0. So this is the final solution. Now we will discuss one more problem, that is p minus q is equal to log x plus y. And now we can see that this is also of the form p plus q equal to r. Therefore, this is a Lagrange's equation. So the first one is a Lagrange's equation. Therefore, the first step is writing auxiliary equation, that is dx by p equal to dy by q is equal to dz by r. This is the auxiliary equation. Now in this case, you find out the values of p, q, r. So you can see that p is 1, so dx by 1, and q is minus 1, therefore dy is minus 1, and dz by log x plus y. So this is our auxiliary equation. I'll take it as second equation. Now for finding solution of the first equation, you have to find two independent solutions of equation number 2. For that, you find out any two ratios. So you can see that from first and second ratio, so you can write from first and second ratio. We have dx is equal to minus dy. Therefore, integrating, we will get x equal to minus y plus constant of integration a. So that we can write here x plus y equal to a. So this is one solution of the auxiliary equation. Now then we have to find out one more solution. So now here you see, if you are taking first and third, you cannot integrate, and if you are taking second and third also, you cannot integrate. And if you are going for any other equivalent ratio like dx minus dy and dx plus dy, then also it is not possible here. So in such cases, we can use another method, another rule. There is another rule, that is, you see here, one solution is x plus y equal to a. And now in the third ratio, it contains the term x plus y. So instead of x plus y, you can write the constant a there, because from equation number 3, x plus y is a. So therefore, what we can do is, we can take first and third ratio or second and third ratio. Anything is possible here. I'll take first and third ratio. So taking first and third ratios, so we can write dx by 1 is equal to dz by log x plus y. And now you see that x plus y is a constant. So we can substitute it here. Dx by 1 is equal to dz by log a. So that we can integrate this equation. Now for the simplicity, I'll be writing it as log a into dx equal to dz. So now integrating, and a is a constant, therefore log a is also a constant. Log a into integral dx is x and integral dz is z plus constant of integration, I'll write it as b. Now substitute back for the value of a here, so that you can write log x plus y into x equal to z plus b, or z minus, not z, it is x into log x plus y minus z equal to b. So this is the second solution of the auxiliary equation. Therefore, by a theorem, general solution of the given equation, that is given Lagrange equation is f of u v equal to 0, and u is x plus y and v is x into log x plus y minus z equal to 0. So this is the general solution. Now to conclude, I'll explain the method once again. First of all, identify the given equation as a Lagrange equation. That is, you check whether the equation is of the form P plus Q equal to R. If it is a Lagrange equation, write down auxiliary equation, and then you will be getting 3 ratios, and using some method of grouping or method of multipliers, you find out 2 independent solution of this auxiliary equation, and take the first independent solution as u equal to a, and the second one write it in the form v equal to b. Then the general solution of the equation will be f of uv equal to 0. Substituting the values of u and v, we will be getting the general solution of the given equation. So in the coming video, I'll explain some problems to solve Lagrange's equation by using method of multipliers.